So ultimately, the order of u and w don't actually matter, and similarly for w and v. So we can evaluate u, v, w in any order. We don't have to use a topological order or post order. It doesn't really matter. But we do need to evaluate L in increasing order. Because for any pair UVL, it depends on smaller values of L. So that's the key thing there. So the evaluation order isn't too bad because we have all that freedom, but the downside with all the freedom is this loop is huge. So how many subproblems do we have? Well, we have U can be any value, so there's size of V options for U and V. We'll do this to all pairs each. And then inside the loop, we have to do O of V work, so to compute them in. Because we have to try it over all possible vertex values. So already we're looking at something that's O of V cubed. Now, the straightforward way to do it, that has single source sorted path for every possible start node, this runs in O of V to the fourth time. So if L can take up to V possible values too, like it would have in the previous one. So in the previous one, remember, we plug in V minus 1. So that's V possible values. Well, then we get V to the fourth too, and this is not really helping us. The good thing is because we're dividing by 2 each time, that this will only be log V. Because there's V possible values of L, or the total value of L can be V, but because you're always having it, that restricts how many values could actually appear. Now, of course, if L is not a power of 2, this technically won't work, but we can always use the default value. L is 2 to the seal of log V, and this is something less than 2V, but it's still at least the size of V minus 1. So we just picked the smallest L that's bigger than the size of V minus 1, but is still a power of 2. And so that way, when we evaluate the number of possibilities for L, well, it's going to be log of this. So because we divide L each time, the number of subproblems, or number of ways to input L, is going to be approximately log base 2 of L, which is at most log base 2 of 2V. Because of this inequality. So for correctness, we just needed to be bigger than this, but for speed and efficiency, we need the other inequality. And that completes the algorithm.